Changelings are a clade of highly derived birds of the late Thermocene, descended from the strak birds, and are found over most of the Western Hemisphere, and which have adapted to reproduce in a very unusual manner, unlike any other bird, or indeed vertebrate, in the world. Adults are a number of species of small and relatively ordinary finch-like birds, approximately 2 to 7 inches in length from head to tail, and weighing just a few tenths of an ounce to as much as 2 or 3 ounces. Their young, however, are so remarkably different in both form and behavior that to the untrained eye, they could easily pass not only for different species, but different orders of animal entirely. They are the first land vertebrate known to have independently re-evolved a metamorphosis-driven development since the first tetrapods came to land on Earth more than 500 million years ago. The strange life cycle of the changeling begins with an egg unlike that of any other bird ever to live. It is perhaps most initially remarkable for its diminutive size, no larger than a grain of rice. A closer inspection further reveals that these tiny eggs are not only minuscule, but extremely specialized in a way that one would never suspect, judging by the very primitive form of the adult bird. They are round and bead-like and totally lack a calcified shell, being protected only by a permeable, semi-opaque membrane with a consistency akin to rubber. They more closely resemble the egg of a frog than any amniote. Because the eggs are so small and, additionally, so simple in construction compared to those of other birds her size, the female produces them extraordinarily quickly, at peak breeding season laying one every 90 minutes or so for most of the day, in comparison to the 24 hours it takes for most other similarly sized birds to produce their eggs. She needs to produce a large number of eggs, more than she can ever expect to survive to adulthood, because her method of brooding is one heavily reliant on chance. She will take no part in rearing any of them. She doesn't need to. Remarkably, they will manage on their own. Changelings lay their eggs directly within food sources her offspring will eat after hatching, namely stashes of meat that the mother has produced and hidden out of sight in a secure place, such as the abandoned burrow of some small animal, a crevice in rock, or a small hollow in a tree. Opening one of the carcasses in the larder with her bill to reveal the muscle tissue, she deposits a single tiny rubbery egg, which is slightly sticky and adheres to the tissue. She then abandons it, only to return and deposit another into another carcass in the larder within 2 hours, anywhere from just a couple to a dozen or more times, depending on the size of the food stash she has hidden there, leaving the tiny eggs completely on their own to develop afterwards. A female will set up as many as 20 such larders a season in seasonal climates, continuously catching and stashing larders of prey in which to lay her eggs, and upwards of 100 in the tropics, where high ambient temperatures may allow breeding all year long. Different species have distinct preferences for the food source used, which will be fed upon by their young, with some actively preying on small animals and insects, and still others preferring to scavenge bits and pieces of meat from carcasses and use these as its nurseries. All species, however, select their nursery sites based on 2 factors: seclusion from predators, which may harm either their young or steal the nursery itself, and warmth. The eggs will not develop in conditions which stay below 90 degrees Fahrenheit for long. In hot weather, and indeed, it is only during very warm conditions that changelings will be driven to breed, each tiny egg will begin developing in the ambient warmth. It is so small and contains so little egg yolk that to survive, it must hatch in 2 to 4 days into what can scarcely be called a nestling. The chick indeed hatches so prematurely as to resemble little more than a blind, indeed eyeless, pink worm, which pulls itself along with only 3 visibly functional structures. But these structures, a pair of tiny arms edged in keratin spurs, and a truly minute hooked beak, are especially well developed, as if all of what little energy was available to the embryo in the egg went into their development. And in effect, this is what occurred, for they are extremely important now. Eyes and even many organs can wait. With no parent in sight, and indeed no sight at all, it immediately begins using them to feed itself, slowly burrowing its way into the mound of insect and small animal carcasses that will remain its nursery for the first stage of its life. It will remain within its natal home for approximately 5 weeks, gnawing on the stockpile of protein its mother provided it, and growing considerably in size from a few hundredths of an ounce up to double its adult weight, as much as 7 ounces in the largest species. It feeds on every part of the prey animals provided to it, even after they have dried out to little more than husks or, in wet conditions, begun to rot. An iron stomach of extreme acidity, apparently killing any infectious agents. It consumes the skin, the feathers, even the scales, and particularly the bones, storing the calcium to rely on later to produce its own. At this stage, the larvae is little more than fat and cartilage. Then, when it has sufficiently fed and its larder is used up, or nearly so, it retreats to the edges of its nest. At this point, remarkably, it still resembles a larvae. It is still without eyes or visible limbs, except for the 2 arms on its chest and the sharp mandibles it has used for its short life so far to cut apart the carcasses that it has relied on for food. It has no plumage to speak of, no hind legs, and until it was 10 or 12 days old, had no functioning lungs. It had breathed entirely through a moist, permeable skin until this time, keeping itself moist enough to respire by burrowing inside the carcasses in the larder provided by its mother to feed upon until it could tolerate the drier surroundings of the nest. It had at hatching only the earliest, most rudimentary mass of cells where its brain would eventually form, and is still hardly capable of more than the most instinctive response to stimuli at this stage. And yet, it has attained all the nutrients it requires to produce a fully fledged bird. It begins to secrete a mucus covering from its snapping jaws, which it wraps around its body with twisting motions, incorporating soil, bark, and any other organic detritus in the nest cavity into what becomes a chrysalis of sorts. When the covering is complete, the fetal birdworm becomes still. It has produced, in effect, a new egg in which it will now finish its development. Over the course of anywhere from a few weeks to several months, the creature now undergoes a massive transformation, absorbing the thick layer of fat it built up around its body as a larvae and redistributing the nutrients in the form of legs, bones, and organs. Its larval beak and the spurs on its wings are shed, to be replaced by wholly new structures. The blunter, longer adult bills and feather quills. Its weight is halved, as much of the fat is burned away in the process of development, but eventually, the animal hatches for the second time, now from an egg of its own creation, as a fully fledged and independent bird, already as large as its parents and fully sexually mature. It takes only a few minutes for the fledgling to pull itself out of the silken wrapping it spun and to dry its wings before it leaves the nest, along with any of its siblings, taking flight and within only days courting a mate. The sex of the adult bird is determined only after its larval stage, at which point it is wholly sexless. Larvae with few siblings or exceptionally large larders, which eat the most and reach the largest sizes, become females. Crowded nest sites, or those stocked with only a minimal food supply, become males. In very overcrowded nests, or those with insufficient food, the female-to-be larvae will cannibalize their smaller male-to-be siblings. A male island firetail changeling, newly mature and very willing to breed, courts a larger, older female. He must do so with extreme caution, for an unwilling female will not hesitate to kill an unwanted suitor and add him to her larder. The island firetail is a basal changeling species found in the Kieran Islands, one of only two endemic to the island chain and the easternmost species in the late Thermocene, 150 million years post-establishment. The adults of this species, like all changelings, while obviously dimorphic, give little impression of just how derived their lineage has become. Whereas more derived changelings exhibit more stark dimorphism, such in this species is limited mainly to some slight color differences in the longer, thinner bill of the male, adapted to drink nectar and catch small insects, whereas the stout-billed female hunts large flying insects and smaller birds in addition to feeding on fruits and seeds. Her offspring are raised in larders of large-bodied insects and the occasional smaller bird, mostly prey caught on the wing. Male and female changelings alike are brightly colored as adults, for neither must sit vulnerable whilst incubating eggs, though both sexes are still very distinctly dimorphic. Males and females have different diets, the larger female having a stout and slightly hooked beak suited to feeding on insects and animal protein, as well as seeds and a small quantity of vegetable matter, while the male eats mostly sugar, with a long bill suited to probing into flowers and breaking into fruit, though he also feeds on soft-bodied grubs and small flying insects. The sole goal in life of the tiny male changeling is to mate as many females as possible, and he dedicates his entire life to doing so, feeding on high-energy fruit and sugary nectar, and taking in only enough nutrition to maintain himself for a few weeks before he dies of exhaustion. The female, up to 2 times larger than her partner and just as promiscuous, dedicates her life to nesting and creating nurseries, stockpiling larders with prey, and mating and laying eggs for as long as the warm weather allows. Tropical climates can allow for a continuous progression of generations every 2 to 3 months year-round, and females in these environments typically deplete their own resources eventually, and rarely survive beyond 2 or 3 years of their hatching as adults. In temperate climates, where females will only be able to breed a few months out of the year, they may live considerably longer, up to 10 years, and may migrate seasonally when not breeding to milder climates. Males of all species live far shorter lives, a maximum of a month as adults in the tropics, and usually before the onset of winter in temperate ones. For spending all of their adult lives mating, they do not make any effort to build up fat reserves to survive the cold season. Temperate climates typically see the birth of 2 generations, one which hatches in the spring and breeds at the start of summer, and another which hatches toward the middle of summer, pupating in the fall and spending the winter dormant in this stage to hatch in the spring. The life cycle of the changeling bird, from soft-shelled egg to newborn larvae, to 5-week-old larvae, to pupating chick, to hatching to mature adult female, the latter 2 stages being separated by only a few minutes. The evolutionary process which has led to the changeling's extreme life cycle were many-fold. The changeling's earliest ancestor were the strack birds, carnivores which were highly nomadic and followed large predators from kill to kill, making rearing their young for a long period in a nest difficult. A selective process began in which the chicks of one strackbird species must have gradually become slightly more developed at birth, no longer dependent on having food stuffed directly into their gapes, but able to feed themselves so long as tidbits of food were dropped in their nest, perhaps locating it by smell and then engulfing it. This reduced the length of time the parent had to spend at the nest attending them. Later, this progressed to tearing small parts off the food on their own accord with a beak that was sharp from hatching. In exchange, other body parts of the nestling would be less developed at hatching and would catch up later before they were needed. In the very warm climate of the Thermocene, even naked nestlings could stay warm on their own without being brooded by parents. And this in conjunction with a simplified feeding behavior which only required that prey items be dropped in the nest once and then shared by all the young, would allow parent birds to raise more young at a time for the same level of effort compared to a more typical parent bird, which must make constant trips to the nest with single, bite-sized food items for its young. Not having to spend time brooding the chicks, and with providing food greatly simplified, a single large meal might feed a nest of nippy youngsters for a long period. They could then begin still more nests in a season, stock them with larders, and then leave to follow the large predators upon which they depended for food. Over countless generations, the process became more and more derived from its ancestral state. The chicks hatched sooner, still able to feed themselves, but at the expense of almost all of their bodily development, until the very eggs the mother produced no longer needed to carry more than the smallest quantity of nutrition to nourish them until the larder was provided. Now the parents could move on to start another brood before their previous young even hatched, with the larder becoming both a home and an all-you-can-eat buffet that the chicks would then feed on at their leisure while their parents raised many more broods. The chicks at this stage now hatched effectively as embryos. Only their jaws, stomachs, and the start of their wings formed at all, and would be able to find all of the calcium and nutrition they would need in the meaty meals left by their long-gone parents before they were born. Thus, it became unnecessary for the female to lay hard-shelled eggs. As the young became more larval, the eggs became smaller and, in turn, more easily produced, letting the mother produce still more offspring, enough to still ensure some survived, even though this new hands-off method of parenting surely exposed many unguarded nests to predators. The changelings' ancestors became extreme R strategists, flooding their habitat with so many broods of offspring that some were always bound to survive. The rapid turnover of individuals also made for rapid natural selection, turning the two formerly similar sexes into increasingly divergent creatures which would not compete for resources even at very high population density. The evolution of the changeling's reproductive cycle is very similar to the process through which advanced earth insects, and some Serina crickets as well, developed metamorphosis-driven development. All three, in particular, produce a sort of second egg after their first hatching, in which to develop into their adult forms after gorging on food as larvae. A chrysalis, or cocoon, in the changeling, this seems to be the most recent adaptation, and simply serves as a protective bag in which the young develops, protecting it from the elements and hiding its scent from predators. Earlier ancestors likely pupated within their nest cavities, exposed and without an egg, as tadpoles develop into frogs whilst in a free living state. For unlike the caterpillars of butterflies, which literally dissolve and reform whilst in their pupae and cannot survive outside them, the young of the changeling simply absorbs certain body tissues and repurposes the nutrients to build new ones. Thus, the considerable loss of weight as it burns energy in the process. Speaking very broadly, the changeling consumes most of its body mass and uses the resulting energy to build its adult form during its metamorphosis, and is thus much more like an amphibian than an insect. The evolution of the unique process could either be viewed as an extreme specialization of the amniote reproductive method, or an extreme regression back to a larval, amphibian-like development with a shell-less egg and metamorphosis before reaching adulthood, depending on one's viewpoint. Of no question, however, is that the changeling, so seemingly plain in adulthood but remarkable in infancy, is surely one of Serina's most fascinatingly derived birds. Dawn in late winter, somewhere in the southernmost boreal region of Stevlandia, 150 million years post-establishment. Frost coats the grass with a shimmering veil of icy silver, and rays of sunlight catch the exhaled breath of the world's largest land predator's terrestrial roar. The nesting season will soon be here, and this male Goliath tyrant Serin is sporting his red accented wing plumage, a visual signal that complements his long-ranging calls to tell other males not to dare invade his land. A 4,500-pound, 30-foot-long canary, this is a creature simply too immense to brood its own eggs, and so soon the females will venture to nearby volcanic springs, burying their eggs in mounds above geothermal heat to incubate them. It is a resource not scarce in the Thermocene, and one which has allowed their enormous size to arise. This resource will diminish in future eras, and it may be related that there will be no larger land carnivore to set foot upon the world of birds for over 100 million years.